All right, question number 3 wants us to determine if the distribution is a discrete probability distribution. And so what we need to do is just add up the probabilities, check to make sure all of them are between 0 and 1, which it looks like they are. None of them are negative. And if we add 20, 40, 60, 80, 100, all of these add up to be 1. So we'll say yes, the sum of the probabilities equal 1. That is true. Yes, because the sum of the probabilities is equal to 1 and each probability is between 0 and 1 inclusive. Yes. So this is the more correct definition. Just because they add to 1 doesn't mean it's a distribution, because you could have some negative values. So you want to make sure you add on and they're between 0 and 1. All right, number 4, we have 8 parts. It says in the probability distribution to the right, the random variable X represents the number of marriages an individual aged 15 years or older has been involved in. We're going to complete A through F. So it says verify that this is a discrete distribution. So what I'm going to do is I'm going to copy this in Excel. I'm going to open this up, enable editing, and I'm going to let it sum this for me. So I'm going to go to formulas. This is the auto sum, and it's highlighted B2, which is B2 all the way to B7. We hit enter, and it adds up to be 1. Nothing is negative, nothing is greater than 1, so we're going to say this distribution is, this is a discrete probability distribution because all the probabilities are between 0 and 1, and the sum of the probabilities is equal to 1. Okay. Next part, we're going to draw a graph of the probability distribution. Describe the shape. So at 0, we're at a height of 2.73. So this is out, this is out, this is way too high. This is the only one that would match just looking at 0, about 2.73. So I could pick this one. It looks like it would be, I would say, skewed to the right. It slopes down. So the distribution is uniform, bimodal, multimodal, has one mode. I guess we're going to say the mode, the highest point, one mode, that's the most, and is roughly skewed to the right. We're going to compute and interpret the mean of the random variable X. So we're going to find the mean. So since I already have this in Excel, I'm going to make this column over here. I'm going to say equal. I'm going to click this one times this one, and then I'm going to drag this down. Alright, so this should be A3, B3, this should be A4, B4. Okay, good. So now I'm going to sum those up, and this gives me my mean, 0.914. 0.914. What do they want me to do? Do not round, 0.914. Which of the following interpretations of the mean is correct? So, if many individuals aged 15 or older were surveyed, the sample mean number of marriages should be close to the mean of the random variable. That looks close. If any number of individuals aged 15 or older were surveyed, the sample mean number of marriages should be close to the mean of the random variable. What is that? What's the difference? Many, the sample mean, any number were surveyed, the sample mean should be close to the mean of the random variable. Are those the same? If many, if any number, not any number, it needs to be many of them, so B would not be that good. If many random selected individuals aged 15 or older were surveyed, the observed number of marriages would be less than the mean. If many were selected, 40 to 49. If many were selected, age 15 or older, the observed number of marriages would be equal to the mean. So not exactly equal. So if many, it should be close to the mean. It's just an estimate. All right, we're going to compute the standard deviation. Okay, so let me show you the method I think is best. We're going to use that second formula, which we're going to do the x squared. Let me go back to the textbook. The x squared times the probability, add those up, and subtract the mean squared. So let me get there. 1, 2, 3, 4. That's the mean. 5. This one. So we're going to just square the x value and multiply it times the probability. We're going to get that. We're going to add those up. That total, we're going to subtract this mean squared, and we're going to do the square root of that sum, and that will give us the standard deviation. So in Excel, I'm going to put equal, and this is going to be the first part of that formula. So we're going to do this times itself. So that's going to be the x squared. No, I'm sorry. Let me back that up. We're going to do this number times itself. It's x squared, which would just be 0. So you multiply that times itself, then you multiply times the probability. So let me go back. You do the x squared and then times the probability. So that is me multiplying this number twice and then times the probability. Once I do it once and I drag it, I'm going to drag it to the first row. It should give me a similar formula. When I click here, it's A3, which is x twice, and then times that. So it's following. So I'm going to do this, drag it down, gives me all those values. I'm going to sum those up. This is what we call E, expected value of x squared. I do want you to notice that expected value, if I can go back to the textbook, when you go and find the mean is just multiplying a single x times the probability, okay, and it's adding them all up. The one we're doing is just squaring the x and then times the probability and add them up. So it's very close to the mean, so it's not a whole lot difference. So I do want you to make that connection. All right, so we found x squared. So now I can find my standard deviation. So I'm going to say equal. We're going to do this number, e of x squared, minus, and I'm going to do this in parentheses, the mean. This is the mean, but the mean has to be squared. Okay. And in parentheses to force it to do that first. So we're going to get this. Okay, so the part that I've completed now, I've done this sum minus the mean squared. Now I have to do the square root of that value. So now I'm going to say SQRT. So I got to do equal SQRT for square root of this number. And this will give me my standard deviation. And they want to round to 1 decimal place. So that's going to be 0.7. What is the probability that a randomly selected individual 15 years or older was involved in 2 marriages? So use the probability table. Involved in 2 marriages is 0.116. And then what's the probability a randomly selected 15 years or older was involved in at least 2? At least 2. At least 2 means to add up 2, 3, 4, and 5. So I can add up all of these, or I can do 1 minus these 2 here. Either way, you will get the same thing. So this is kind of like that at least probability. So I'm going to say, I just copy Control C, Control V. I'm going to find the sum of those, and I get 0.149. Now if I do right here, I'm going to do equals 1 minus, and I'm going to just subtract these two that I don't want, minus this one. So minus 0 and 1, you get the same thing, 0.149. So you got two ways to compute that.